Hello, let's do the New York Times Medium Sudoku from May 7th, 2024. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. So let's go over some terminology first. This is a cell. There's 81 of them in the grid. It's a 9 by 9 grid of cells. This is a row of cells. Rows have 9 cells. This is a column, also has 9 cells. And this is a box. Only the bold outlined 3 by 3s are considered boxes. Now I call those out because in Sudoku rules, those are the 3 things that must have the digits 1 to 9 exactly once each. Every row, every column, and every box has the digits 1 to 9 exactly once each. Those are Sudoku rules. All right, additionally, some additional terms. We have bands. A row of 3 boxes is a band. There are 3 of them in the puzzle. And we have stacks. A column of 3 boxes is a stack. Okay, I'm going to be taking a systematic approach to this solve, and I'm going to be going step by step very slowly. And so that's why these solves are significantly longer than my hard solves, but the idea is for them to be instruction aids so that you can get an idea of how all of these different techniques work that I do utilize in the hard solves. Okay, so we are going to go band by band first. We're going to start with the top band, then the middle band, then the last band. We're going to be looking for the same 3 things in each band. I'll go over them as we find them. So the first thing we're going to look for is repeated digits in the band, specifically when there's 2 out of the 3 of a digit placed. Now, why do I know that there's going to be 3 of each digit? Well, because there's 3 rows in the band. There's also 3 boxes in the band, both of which say that there are going to be 1 per. And so since there are 3 of them, there are going to be 3 of each digit in total. So what I'm going to do is I'm going to start with I'm going to compare each box against each other box. And so since there's 3 boxes, we need 3 comparisons. Box 1 versus box 2, box 1 versus box 3, and box 2 versus box 3. But the order I'm going to go in is going to save us a little bit of time because I'm going to start with the box that has the fewest givens. In this case, this has 1 given in it. This is a given because they have given us the digit. I'm going to start with 1 given, and I'm going to compare that against these other 2. So box 3 against boxes 1 and 2. And I'm going to look for another 5. And I do see a 5 here and not here. So now we have found that there are 2 5s in this band that have been given. We just have to find where the third one is. Well, if these 2 are in these 2 rows and these 2 boxes, then the final 5 is going to be in one of these 3 cells only. So we've already reduced it to only 3 cells. That's always going to happen when we find 2 out of the 3. Now, these 3 cells may be further restricted. There could be digits already given in there that aren't 5, or there could be some 5s down here somewhere looking up, peeking up and removing the 5, because you can't repeat in the column either. In this case, there is not. But we still want to remember that that final 5 is in one of these 3 cells. And so what I'm going to do is I'm going to use the corner mark for that mode. Now, this is corner mark mode. This is center mark mode. You can see why they're named that way. Center marks go in the middle of the cell, and corner marks go in the corner of the cell. Red just means it's not actually possible anymore for trivial reasons. That is an option I have enabled. It's because we have this 1 and this 4 here. It doesn't tell you about any non-trivial reasons it's wrong, and it does not base it off the solution to the puzzle. It bases it off of your current state of where you've placed digits. So I'm going to corner mark 5 into these 3 cells. Now, what that means is that in this box, the 5 has been limited to these 3 cells. So in general, corner marks are a box-centric marking. I'll go over what center marks mean when we do them. So we're going to use a corner mark to mean that in that box that the corner marks exist in, we have reduced that digit to some comprehensive list of cells. It's an exhaustive list of cells. We don't want to do this because 5 can still be here. We want to mark every cell that 5 can be in. And we're only going to corner mark if it's down to 3 or fewer cells in a box. And even when it's 2, it doesn't matter where they are. But when it's 3, we're only going to do it when they're in a line. Okay. And that's because we don't want to make a mistake and think that we're like, so if I mark like this, right? Ignoring the red. If I mark like this, and it could be in these 3 cells. Here, I'm going to use 8 just to demonstrate that. Let's say 8 was reduced to these 3, and I marked that. I might miss, like when I'm scanning this row or something, I might miss that this 8 is not restricted to just these 2, that it also could be here, and I could make a mistake based on that. Anyway, so that's corner marking. So we're going to mark 5s there. And we're going to do this for all repeated digits. So 5 is the only one that involves box 3. Now I'm going to look at of these two. This is obviously the one with the fewest givens. We're going to look for 3, 4, and 7 in here. We don't see a 3, but we do see a 4 and 7. We'll take those one at a time. The 4s look in here, putting a 4 up here. And the 7s, take it out of these. And it puts a 7 up here, but this 7 down here, remember, I'm always scanning down to try to look for those. This 7 down here says not in this cell. Now, if I had accidentally done so, if I have the red marks on, it will tell me about that. But there will be things later, like pointing, for example, that you're still going to want to scan down for. So I would not rely on the red marks. I would use the red marks only to be like, oops, I didn't see that. Not a, oh, because I didn't see that, maybe I should take a closer look at everything else, because that means I didn't look carefully enough. I would not use it as a end-all, be-all oracle of whether it can be there or not. Now, towards the end of the puzzle, we are going to use the red marks to just speed up the end, but that's just, single after single after single. But we'll get there. Okay, so those are all the repeated digits in the band. That's the first thing we look for. The next thing that we're going to look for, 2 out of 3 things, is a filled box row. Now, a box row is just a row, the 3 cells that are in a row within a box, right? We call this a box row. So we're going to look for a filled box row, like this one, where we know every single digit. We know what the 3 digits that go in that box row are. In this case, it's 2, 4, and 5. And so what we can do is we can look at the 2 rows that it's not in the 2 boxes it's not in. So these 12 cells here, you can see I started with this, and I'm just doing the ones it's not in. And I'm going to look for any digits that aren't already in the box. Now, unfortunately, there aren't any. So that's it, and that's the only box row that was filled. So we're going to move on from that. Now, the next thing I'm going to look for is any row or box that have been reduced to 4 or fewer open cells, which means that there are 4 or fewer digits left that need to be placed in that row or box. Now, I'm going to start with whatever I see as the least cells remaining. So this box has 3 cells remaining. That means there's only 3 digits left to place in this box. And let's think about what those 3 digits are. We have the 1, 2. We need a 3. We have 4, 5, 6, 7. We need 8, 9. So it's 3, 8, 9. So what I want to do is I want to be looking for 3s, 8s, and 9s kind of in its band and in its stack that isn't in the box. 3s, 8s, and 9s. So we see we have this 3 here, but it doesn't help. We also have this 3 here. That takes 3 out of this cell. And so one thing we may notice, you want to be thinking about a bunch of stuff, and as you gain experience, the stuff to think about will become more natural. But in this case, we have actually reduced 3 to 2 cells in this box, and so we can corner mark that. Now, as soon as we do that, what we find is that this does what's called pointing. So pointing is when a box has restricted where a digit can go, that then restricts where that digit can go in a row or column. In this case, a column. So these 3s line up in a column, and that means that the rest of the column can't be 3. So to go slowly, this box, where does 3 go? It's going to go here or here. The box must have a 3 by Sudoku rules. And so in the one in single final solution to this puzzle, there will be a 3 here, or there will be a 3 here, guaranteed. Those are the only 2 options. If you look at the final solution, if you go to the end of the video and you look at where 3 is in this box, it'll be here or here, guaranteed. Whichever case that happens in, this column doesn't care. All it cares about is that, okay, there's going to be a 3 in the column, and it's going to be in one of these 2 cells, right? These share the same column. So wherever the 3 ends up, the rest of these have the same result. They are not 3. And so that's why it's called pointing, because these kind of line up. You can draw an arrow, and they point at the rest of the column, and they say, no more 3s. I already know where the 3 is in this column, kind of. It's up here. So it's not going to be down here for sure. So these are not 3. And we have this 3 looking down saying these are not 3, right? So I'm actually going to just immediately corner mark 3s here. We could have gotten that when we did the vertical, but if you get pointing, if you have any way to remember that pointing any better, I recommend doing it now before you forget. So that was the only thing we saw. But the other thing I'm going to do is I'm going to center mark this box. Now, center marking is a per cell marking. It's a cell-centric marking. So I'm going to look at this individual cell here, and I'm going to think what possible digits are still available that could be the digit that goes in this cell in the solution. And so we want a comprehensive list of them. Well, it can't be a 1 or a 2 It can't be a 3. There's already a 3 in the column. It can't be 4, 5, 6, or 7. Those are all in the box already. And so the only digits that it can be are 8 and 9. So the comprehensive list of digits that this cell could be in the solution is only 8 or 9. So it will be one of those two, an 8 or a 9. And when it's down to 3 or fewer, I'm going to use center marks to remember that. And center marks are going to be we call those candidates. So the 8 and 9 are candidates because you can imagine like a candidate for election, right? They're candidates for what could go in that cell. And it's an exhaustive list. Again, we're doing exhaustive lists here. We're not trying to shortchange ourselves. We're not trying to like accidentally not list the one that it ends up being because we don't know which one it ends up being. So 8 and 9 are what this will end up being. We're going to use center marks to denote that. Now these we know are down to 3, 8, 9. We listed them earlier. And so anytime we're down to 3 or fewer, I think it's generally safe to just center mark that, unless you think you're getting too cluttered and you don't want to clutter too much more. But we may potentially need these center marks later in order to discover, for example, a naked triple. We'll go over those when we find those. Okay, so we were looking at rows and boxes down to 4 or fewer open cells. There is another row down to 4. It's this row here. We want to first think about what the digits are. The candidates, they are the digits that are not yet placed on this row are 1, 6, 8, 9. So I'm thinking about 1s, 6s, 8s, 9s. So I see that this cell here cannot be a 6. Now that's pretty powerful because I noticed that 3 of these are all in the same box. It's just this one that's kind of the outlier that's in a different box. And this one can't be 6. And so the consequence of that is that the 6 for the row is going to be in one of these 3 cells. So because those are all in the same box, I can corner mark that. And what we've done is actually called claiming. Claiming is very similar to pointing, except we've restricted where a digit can go in a row or column, but in this case, row. So we've restricted where a digit can go in a row, and that has, as a result, restricted where the digit can go in its box, in a box. So because this row needs a 6, and the only box that it can put a 6 into, it's going to be one of these 3 cells, is this box 3 here. The rest of box 3 cannot be a 6. So the result is we can't put a 6 up here. We already knew this 6 said not down here. We did not know that these could not be 6 until we put these corner marks in for the row. Now, the only reason we could corner mark for the row is because the remaining cells all happen to be in the same box. Now, as a result, this row is going to need a 6, or alternatively, remember we were looking for buddies for our digits. Well, this 6, it's got a buddy somewhere over here, right? We don't know which one it's placed in, but our buddy system doesn't really care. It's going to take 6s out of these cells, and there's only going to be a 6 available up here. But in addition to that, I'm seeing we have this 6 and this 6 down here, taking it out of these 2 cells. So we found our first hidden single. There's only one cell in this whole box that can be 6, and so that cell must be 6 because the box needs a 6. And if we don't put a 6 in this cell, we're not going to be able to put a 6 in any cell, and that's bad. So we're going to place the 6. That's called a single, right? There's only one single location in the box that can be 6. We call it a hidden single, hidden being kind of the key word. That means that we're dealing with either a row, column, or box for the logic, as opposed to an individual cell for the logic. If we're working with individual cells, then that would be called a naked technique. Okay, so we got this 6 placed. Very nice. And that was because we looked at the candidates for this row. We haven't even finished looking at the candidates for this row, so let's keep looking. We've got the 1, what was it again? 1, 6, 8, 9. So over here, I've got these 2 cells cannot be 8. This cell can't even be 8, 9. So these are worth marking as 1, 1, 6, 9. And we also know this can't be 1 and this can't be 9. So this cell's down to 1, 6. This cell's down to 6, 9. That's very nice. We know this cell can't be 6. So we can fill 1, 8, 9 here. And this can be any of 1, 6, 8, 9. So we're not going to fill it. It's just going to clutter our grid. So see how it's going to start looking really busy, and it's going to start getting in the way of being able to scan for things properly. And we're never going to need to see when there's 4 candidates in a cell, at least for this puzzle. Okay, so in general, New York Times puzzles, you're not going to need that. Okay, so that was this row. Are there any other rows or boxes down to 4 or fewer? Especially because I placed this 6, I want to relook for to see if its box or row might be reduced now. It's not, though. So we are now done with that band. And we're going to do the exact same thing on band 2. So I'm going to start with this 8, 9, right? It's the box with the fewest givens. I don't see any 8s over here, but I do see a 9. So those 9s affect this middle box, putting a 9 in one of these 2 cells. And then I can just do the 3, 6, 7. We have the 6 and the 7. So the 2 6s look in, putting a 6 over here. The 2 7s look in. This, remember, we're always scanning up and down. I see this 7 here, and this 9 is not a 7. And so there's only one place for 7, so we have a hidden single 7 in the box. Very nice. Now that 7, we're going to scan to see if that affects any of our markings. You can see the red mark does help with that, to sort of call that out. But even if not, when you place that digit, you should be scanning its column, its row, its box for anything that you've marked 7. And here we can remove that marking because we know we thought 7 could be one of these 2. But now that we have updated information, we know this cell can't be 7. And with that updated information, there's only one cell in this box that can be 7 because we only have one 7 corner mark remaining. So I can place that as a hidden single. Now, as soon as I do that, I've already scanned this band. I need to follow up and rescan the band, at least as relates to this 7. So I'm seeing we have all 3 7s, so no buddy to worry about. And did the box or the row get down to 4 or fewer? It did not. Okay, that's the follow-up. That's just the things we're quickly checking when we place a digit. Now we wind back and we say, okay, well, we placed the 7. We got the 6s marked. That's all of our buddies. Oh, no, yeah, we did the 9 already. Okay. And so the next thing we look for, filled box rows. There are none. And we're looking for rows or boxes down to 4 or fewer. There are none. So we can just move on to the next band. Some bands take longer than others. All right, starting from here, we do see we have a buddy 1 over here. And we see these are not filled, or sorry, these are filled with non-1s. And so 1 is only available there. It's a hidden single 1. Now we haven't scanned this stack yet, right? So we don't need to follow up on that. We'll scan the stack in a moment. All right, any other buddies? The 4 and the 6, we're comparing against these and no other buddies. So the last thing we look for is filled box rows. We do have one. So we're going to look at the 2 rows that aren't that row and aren't that box. And we're going to look for any digits that aren't already in the box. So the 1s we don't care about, but with the 2 and the 8 we do. So let's take them one at a time. So one way I like to think about this, is kind of nice memory tool, but we'll prove this logically, is if this 2 did have a buddy in this box, that would cause, so the basic concept here is 2 can't be in these 3 cells. Even though we don't have a buddy for this 2 still can't be in these 3 cells. And so where would the buddy be for that 2? Well, it would be somewhere in here. And in fact, this 2 tells us it wouldn't be in this middle cell. So it's like we have a buddy 2 in one of these 2 cells that's taking it out of these 3, and this 2 takes it out of these 3. And so the result is we have a buddy 2 here, and we have a 2 down here. And I'm going to tell you that those are actually real. Let's prove it. So this 2 looks into this box and says, none of these 3 cells can't be 2. There's already 2 in the row. And 2 can't go in these 3 cells by happenstance that they're filled with non-2s. And so there are only 3 cells in this box that can be 2, and it's going to be these 3. Now remember, pointing, these 2s are going to point and remove 2 from the rest of the row. So importantly, these 3 cells can't be 2 anymore. And this 2 looks into this box saying these can't be 2, and this 2 looks down. And so we can corner mark 2 in one of these 2. And those are the buddies that we had found. So the buddy and the result in this box can all be corner marked at once and save yourself a little time. Or if you want, you can place it in here, do the pointing, and do it here. Or if you want, you can do claiming, right? You can say, in this row, where does 2 go? Well, it can't go in this box or this box. There's already a 2 in this box. And it can't go here. So in this row, 2 ends up in one of these 2, and that claims the rest of the box. Importantly, it can't go here. And so where does it now go in this row? It has to go over here. So however you want to think about it, because the logic is solid, the result is the same. If we got 2 different results from 2 different solid pieces of logic, then we've got a problem. That means the Sudoku is broken. Okay. 2 contradictory results, that would be. All right, so that was the 2. Now we need to do the 8. We're gonna say, well, there had to be a buddy 8 somewhere in here, and then a resulting 8 up here. So we can just corner mark those as well. Okay, so that's why we do the filled box rows. It does tell us about the puzzle, right? It told us that these can't be 8. It told us these can't be 2. It's the important bit, and also that it's restricted in this box. All right, now we look for any rows or boxes down to 4 or fewer open cells. We do not have any. So we are done with all 3 bands now. And now we do the exact same thing with stacks. Just rotate everything 90 degrees. So whenever I said row, just say column instead. Boxes are the same. So I'm going to start with this 1, 4, 6. We don't see any 1s up here. We do see a buddy 4. So these 4s look in, putting a 4 here. And then we do have these two. We have all 3 6s. So we don't need to worry about that. It's done. And then we've got the 7 and the 9. The 7 has a buddy looking down. We do have a 7 over here, but it doesn't help because there was already 6 there. But either way, the 7 ends up in one of these 2 cells. All right, and that's all the buddies, right? That's all the duplicate digits. And so now we want to look for filled box columns. We do not have any. And we're going to look for columns or boxes down to 4 or fewer. This column is down to 4. So we want to think about it. What do we need? We need 2, 5, 8, 9. 2, 5, 8, 9. This bottom cell can't be 8, so it's only 2, 5, 9. This cell can't be 2, so it's 5, 8, 9. This cell can't be 9, so it's 2, 5, 8. And this cell can be any of 2, 5, 8, 9. So we got some cells marked, but it's not super exciting because they're all just 3, and they're not the same 3. Okay, any other columns or boxes down to 4 or fewer? I'm not seeing any. This one is down to 5. All right, next stack. So buddies, we start with this 1. We have these 1s looking in. And that does place the 1 in this box right here. Now we want to follow up on this band because we already scanned the band and we just placed a 1 in there. So we want to look for any buddy 1s. We don't have any. We want to look to see if we've reduced a row or a box down to 4 or fewer. They're both 5, so no. All right, so that was the 1. And now we have the 3, 6, and 7. We've got the 6s looking down here. This 6 looks in. That places the 6. Again, follow up. We have a buddy. 6 is in one of these 2. And did we didn't fill a box row, and we didn't cause any rows or boxes down to 4 or fewer. So that's the follow-up for the 6. We also have the 7. These 2 7s look down. This 7 looks in. Put a 7 in one of these 2. We're getting pretty busy over here, so it's worth looking to see what's going on here. What we do is we have the 3 limited to these 3, the 7 limited to these 2, and the 8 is horizontal here. So, and the 2 is also horizontal here. So we're getting pretty busy, but there's nothing like to do with that at the moment. We'll get back to that if we need to, because there are some things that I could talk about, but they're a little hit or miss, and we're not worried about it in this initial pass over the stacks. Okay, so we got the 6 and the 7 here. So that's all of our buddies. Now we're going to look for filled box columns. We only worry about filled box columns in boxes we haven't like fully marked up. We already fully marked up this box. We found the pointing 3s. If we hadn't found them now, we would have found them. We would have found this 3 and this 3 by looking at the stack, because this is a filled box column. And so we would look at these and we would see, okay, well, the 1, the 6, and the 7 are already placed. The 3 is not. The 3's fake. The 3's virtual buddy is down here, and then that causes a 3 up here. And we already have that marked. We found that by penciling, center marking this box. It's fine. This is a filled box column, so we want to look at these now. These are empty. The 1 and the 6 are already in the box, and the 7. So we're down to just this 2 and 5. So the 2, look at this. The 2 needs a buddy over here to prove that there's no 2 here. And so this is going to end up a 2, and then that's going to put a 2 in here somewhere. So if you want to think about this a little bit more logically, instead of matching that pattern, this 2 is not in here and not in here. So the 2 in this box is in one of these 3. Well, if the 2 is up here for the box, that's going to point. It's going to remove the ability for this cell to be 2. So if this is not 2, we can remove the corner mark, and then that places the only other place for 2 in this box, which is right here. So that's the usefulness of our corner marks. Now, what we did is we removed an 8 corner mark when we did that. We want to look at where the 8s go. There are still 2 left. And luckily, since we only ever corner mark in the row or the column, I only had to look at that row to see, oh, there's 2 8s left. I didn't have to scan the whole box. Another advantage there. So we got the 2. We also had the 5. Now the 5's buddy is going to be here, and it's going to result in a 5 over here. Or if you want to do the logic, 5 ended up here, pointing down, putting 5 in one of these 2. Okay. Now, when I corner marked these 5s, this is something that I want you to be on the lookout for. It can be very important to find, but it can also be very difficult to remember to do or to see. But if you do see it, it's very important. I have corner marked 5s in here, and as soon as I did so, I noticed it's in 2 of the columns, right? We corner marked it in 2 places. So basically what I've noticed is that in this box, the 5 is only going to end up in row 7 or 9. It's not in row 8. And then I scanned left and right, and I saw that in this box, we know that the 5 is also only in those 2 rows, because I know it's not in row 8 because these are filled with non-5s. So the 5 is going to be somewhere in here. Well, if the 5 is in this box only row 7, 9, and in this box only row 7, 9, row 8 is going to need a 5, and it's not in this box, and it's not in this box, and it's not where this 7 is. So we need a 5 in this box, and it can only go in one of these 2 cells. We can corner mark that. And that has told us about claiming. This is a really, really convenient way to notice claiming, because claiming can be really hard to notice. And so in this row, in fact, I should have center marked this row at some point. I think we just placed this too. We haven't followed up on it yet. This is kind of part of the follow-up almost. We did do the 5s after the 2, but that's fine. We'll come back to this. But that means that the 5 is claiming over here, which importantly means these are not 5. This already couldn't be 5 because we had this 5 here, but these aren't 5, and that's non-trivial deduction. Okay, because it requires the claiming of this row. So we found that, but also we placed this too. So we have the buddy. We already did the buddy for that. And then this row has been reduced to 4 digits. So we want to think about what those 4 digits are. We already know it involves the 3, 5, 8. It also involves the 9. So it's 3, 5, 8, 9. Now we're looking to see how 3, 5, 8, and 9 are restricted. We know from these corner mark 5s that these aren't 5, right? So the 5 ends up corner marked over here if we hadn't noticed that earlier. So I think this is all worth marking. This is 3, 8, 9. This can't even be 3 or 5, so this is only 8, 9. We'll get back to this in just a second. Let's finish pencil marking this. These are down to 3, 5, 9. This one's not 9. Now, whenever you center mark a cell, you want to be looking out for if there's any, like, especially if you do 2, but even with 3, you want to look to see if you created a naked pair or naked triple. In this case, in this column, we've created a naked pair. What is a naked pair? Well, let's highlight these so I don't have to keep them highlighted myself. So let's make those green. So what does the center mark mean? We just defined it, right, earlier in the solve. The center mark means this is the exhaustive list of candidates, right? This cell is going to be an 8 or it's going to be a 9. Those are the options. This cell also, it's going to be an 8 or it's going to be a 9. Now the question I'm going to ask is, can these both be 8 or can these both be 9? And the answer is no, because they share a column. The column does not allow repeated digits. We need one of each, exactly one of each. Well, if they can't both be 8 and they can't both be 9, and 8 and 9 are the only digits that can go in them, one of them will be 8 and one of them will be 9, right? If this ends up being, let's just think about this cell on its own. If this cell ends up being an 8, there's a 50% chance it's an 8. Then this cell no longer can be 8, so its list of viable digits is now down to just 9, so it will be a 9. If this cell is not an 8, the only option for it is 9, which then forces this cell to be 8. So there is no world in which 8 and 9 are anywhere else in this column. One of these will be 8, one of these will be 9. They share a column. The column only gets a singular 8 and 9. So so according to the column, it does not care how this resolves if these are an 8 and a 9. You can kind of zoom out a little bit, go, well, these are 8 and 9. When we look at the column, these are 8 and 9. I don't care how they get filled, the rest of the column. So these 2 cells are not 8, 9. So importantly, this corner mark is not a 9 anymore. It can't be. The 9's going to be in one of these 2. So let's get rid of the green there. And now there's only one 9 corner mark in this whole box, so we can place it. That did displace a 2 corner mark, but there's still 2 2s left. This 9 removes the ability of this cell from being 9, so we can clean that up. We're looking at the row to see if there's now only 1 place for 9, but there are still 2 places. So we're okay there. We're also looking to see if this 3, 8 has anything matching up with it to make a pair, but it does not. This 9, we want to follow up. We have all 3 9s already in the band. Did we cause any box row to be filled? No. Did we cause any row or box to be down to 4 or fewer? Yes, we caused this box to be down to 4 or fewer. So let's look at that. Well, first thing I want to look at actually is I want to continue following up on this column, because this column actually only has 2 digits that it hasn't accounted for. Because if we zoom out, we've already accounted for the 8, 9. We've already accounted for the 1, 2, 3, 6, and 7. So there's only 2 digits left that can be placed, which is 4 and 5. And so this ends up being a 4, 5 pair. So we don't need the corner mark 5s, because the 4, 5 pair is more powerful. It's saying 4 and 5 are accounted for, not just in the column, but because these share a box, the 4, 5 is accounted for in the box as well. So these can't be 4, 5 anymore. meaning that this is a pair of whatever the 2 digits remaining in this box are, which is 2 and 8. But actually, this cell can't be 8 because there's an 8 in the row. So this has to be the 2 and this has to be the 8. That 8 does make this cell a 3. That makes this cell a 5 because it can't be 3 anymore, so it must be 5. That makes this cell a 9 and this cell an 8. So we've just finished this whole row. We're going to clean up a little bit. This 2, 5, we're going to see if that did anything. This 8 we placed here causes this to be 9, leaving a 3, 8 pair. We'll follow up on this box in a moment. See, at this point, we've gotten so much, we have to decide what to follow up on. This 9 causes this 6. We're going to follow up on naked singles first and full houses and things like that. A full house is just when you have 8 of the 9 digits placed in a box, row, or column. This 6 makes this a 1. This isn't 6 anymore. We remove this quarter mark 6, which means this is the only place for 6, hidden single. That makes this 6 a hidden single. We're actually done with all the 6s now. Placing this 1 did cause this to be 8 or 9 only. The rest of this row is also just 8, 9. So let's center mark that while we see it. Okay, so now we want to take a step back though. We just got a bunch of digits. So when that happens, let's follow up on this box here. This is a pair for the column because we know where the 3, 8 are. So this is going to be a, let's see, 1, 2, 3, 4, 5. It's going to be a 5, 9 pair. And I'm looking to see if we have any 5s or 9s that help. We do not. And then this is going to be a pair for the column or the rest of the box. They should agree. They agree that it should be 4, 7. We're looking for 4s or 7s, not seeing any. Okay, so that is quite a bit. This stack I would call done, because if we look at it from the columns perspectives, we know where all the digits are. These 5, 9s, this 4, 7, this 4, 5, these pairs are going to resolve in some way, but not vertically. We cannot vertically resolve those pairs. So this stack is done. We don't need to look at it anymore. We placed some digits, and so it might be worth following up on our bands before we move on to this stack. So, for example, we finished this whole row. This is down to 2 digits. Let's actually look at that. We need a 3 and a 4. So there is no, there's nothing looking at those right now. Let's see, we mostly placed in this row, and it doesn't seem to be helping the band very much. We placed this 6 and 1. Okay, so the 1 has a buddy. These ones look in. So we corner mark 1s over here. We placed the 7. 7s are done. 5s we already have marked. Yeah, we already had that. The 6, the 9. Okay, so let's actually move on. We haven't done this stack yet. So if we do this stack, I think that might be fruitful. And then we'll look for some more. If that doesn't finish the puzzle, we'll look for some more things. So I'm going to start with this box right here, the 1, 5, 6, 7. So we do have a buddy 1 down here. So 1 ends up over here. The 5, we have a buddy. These 5s look in. That places this 5. Following up, that gives us this 4 and this 5. That means this isn't 4. Now this row is down to 2 digits. It looks like it's 3 and 4. It's not resolved. This whole box is down to 4 digits. But we haven't finished scanning this stack, so we're not worried about this box yet. We'll do it after the end of the stack. This row, though, is down to 4. So we might as well think about that. We need the 1, 2, 4, 5. This can't be the 2 or 5, so this is 1, 4. And that means the 2 and the 5 over here. Remember, we had this situation earlier, so we can corner mark 2 and 5 over here if we want to. Importantly, that does mean that this row needs a 2, and we've claimed the 2 out of here. The row already has a 5, but it does need a 2. These can't be 2, and this cell can't be 2 because this 2 is here. So there's only one place for 2 in the row, which is right there, so we can place it. I guess we might as well mark that this is down to 1, 3 since I see it. And then this row is now down to 3 digits. It's the 1, 3, and 8. We know the 8 is in one of these two, so we can corner mark that. All right, and these were down to 1, 2, 4, 5. This one can't be 4, so it's 1. Oops, sorry, I meant to be in center mark mode. So it's 1, 2, 5, and this can be any of 1, 2, 4, 5, so we're not worried about it. All right, so this band we got quite a bit out of. We're going to look at this some more. So we got the 1, the 5, the 6. We have all 3 of those now. The 7, we have all 3 of as well. So yeah, we have all 3. The 1 is corner marked. We have the 5 and the 6 in all 3 boxes. And we have the 7 in all 3 boxes. Okay, and so now just comparing these, the 2 does have a buddy. These 2s look up. So 2's in one of these two cells. 7 we already got. The 9 has a buddy. These 9s look up, and this 9 looks in. This isn't 9, so we can place the 9 in this box. That places the 8 as well. Now that comes down here saying this isn't 8. That removed an 8 corner mark. That leaves only this place for 8 in the box. Now both of these can't be 8. That leaves only this place for 8 in this box. This column has been reduced to 2, 5, 9. This isn't a 9. And so now there's only one place for 9 in this column. We're paying attention to that as we pencil. So that's our 9. That resolves this 5, 9 here. Okay, we're doing very well. Basically everywhere we look, we're going to find something at this point, but let's try to stick to the plan as long as possible. We have almost finished with this. We had the 9. What were we even doing? Yes, we had the 2, 7, 9, the 1, we got 6, 5, how about 8? Yeah, so we have these two 8s looking up. That does place this 8. That displaced a 4 corner mark. We're going to do that first because the red marks don't help us with that. So the 4 is going to be placed there, and that places the 2. And now this is what we call a full house. A house is just a generic term for a row, column, or box. And so in this house, we need one more digit left. That's called a full house, and that's the 3. So we can just place the 3. This band is pretty much finishing. That's 3 and 8. This is down to 2 or 5. Oops. Sorry, I did not mean to place the 2. I meant to do 2 5s here. And then this is down to 1 and 9. This 9 tells us the order. That's 1, that's 9. Now this 3 resolved this whole triple as 4, 1, and 3. This pair resolves as well. That resolves this pair. This 7 is no longer here. That places this 7. Over here, we can finish off this 1, the 3 as well. And that leaves us, let's get rid of these corner marks because it leaves us with a 2, 5 pair. And this is the final digit we don't know about. It is the 4. This has to be for the column 2 or 5, but it can't be 5. So that's 2, that's 5, that's 2, that's 5, that's 2. 2 more digits left to place, 3 and 5, that's 5, that's 3, and we're done. I love the collapse at the end. We finish off with a 3 in the corner, which deets for us. All right. And so that's that. We were able to finish the puzzle before we were just able to eke out the final like third of the scan for this last stack because we didn't even scan for filled box columns or 4 or fewer. So that'll happen. I don't know. It's been about at least 50% of the medium puzzles will be solved by the time we get to the end, as long as we follow up properly. If it didn't resolve by the end, there's just a few little things to look for that we don't look for in the first pass, which I go over in the medium solves where that's needed. So I think this was a relatively straightforward puzzle, but it had some interesting spots in it, right? We had a lot of pointing and claiming that we found, especially claiming that we found both through finding lined up stuff. We found, I believe, that the 5s lined up like this, which caused one of these to be 5. Notice this did end up 5. And we also found claiming by penciling rows that were down to 4 or fewer, like penciling this row and seeing that this couldn't be 6. And so that caused 6s to claim in this box, for example. So cool. Hope you enjoyed this. And if you did, then why not leave a like, subscribe, and a kind comment below.